The M1A1 AIM EDSA and M1A2 SEP V2 Abrams tanks are formidable land combat assault weapon systems, but for them to perform their missions effectively, not only must the crews perform well, but the various systems aboard those tanks must perform well, including the hydraulic system. It's your job to make sure of that. The main purpose of the hydraulic system on the Abrams tank is to move heavy objects quickly and easily. Hydraulics elevate and depress the main gun, traverses the gun turret drive system, and opens and closes the turret ammunition doors. Hydraulic power is supplied to the bilge pump and the parking brake system. On the M1A2 SEP V2, hydraulic power is also supplied to the vehicle's cooling system components. The total capacity of the hydraulic system is 19 gallons, which includes 18 gallons in the reservoir and 1 gallon in the hydraulic lines with the system at zero pressure. Before you put the system into operation, visually check the reservoir fluid level and filter indicators. If the fluid level is below the add 1 gallon mark on the gauge, add fluid. If a red filter pop-out indicator is out, push it in. To turn on hydraulic pressure and apply it to the system, turn on the turret power or the master power from the upgraded tank commander's panel. When the system is pressurized, fluid flows from the reservoir to the main pump and the auxiliary pump. The main pump is the primary source of hydraulic power to the vehicle. The auxiliary pump is a secondary source of hydraulic power used when the vehicle engine is off or the main pump isn't working properly. The main or auxiliary pump moves fluid through a filter manifold to the hull distribution manifold, which in turn distributes hydraulic fluid under pressure to several different components. It sends fluid to the hull-mounted bilge pump for use when water enters the hull and must be removed. It sends fluid to the parking brake and its accumulator. It also sends fluid to the Vista gauge or parking system hydraulic pressure gauge. Before fluid returns through the hull distribution manifold to the reservoir, it first travels through a fin-tubed heat exchanger, which removes excess heat from the fluid to prevent it from overheating hydraulic components. A pressure sensor switch on the hull distribution manifold opens and closes, turning the auxiliary pump off and on. The hull distribution manifold sends fluid under pressure to the hull turret slip ring, which enables all electrical and hydraulic system connections between the hull and the turret. The fluid then moves to the turret valve, which distributes hydraulic pressure to all hydraulic components in the turret. The main accumulator, the hydraulic gauge, the ready ammunition door open-closing actuator, the elevation servo, the azimuth servo, and the accumulator for the manual elevation hand pump. The main accumulator builds up and stores hydraulic pressure for the other components to use as needed. The hydraulic gauge indicates the system pressure. The ammunition door actuator opens or closes the ready ammunition door depending on whether the loader's knee switch is depressed or released. A solenoid moves a valve to send oil to one side of the actuator or the other. The turret valve also sends oil to the elevation servo. When the gunner's or commander's station pump switch is pressed, a solenoid moves a valve in the servo to allow oil to flow to the servo. When the control handles are rotated forward or backward, the oil flows to the elevation mechanism cylinder, allowing the main gun to elevate or depress. The same principle applies to the azimuth servo or traverse servo. When the control handles are rotated left or right, oil flowing to the traversing mechanism cylinder causes the turret to rotate. The turret valve also sends fluid to the manual elevation hand pump accumulator. If hydraulic power is lost, the manual elevation hand pump sends oil from the accumulator to the elevation mechanism cylinder, allowing the main gun to elevate or depress. The M1A2 SEP V2 has a thermal management system that provides cooling for the vehicle crew compartment. This system is operated hydraulically. The hull distribution manifold sends fluid by way of the slip ring to the cooling system manifold, or CSM. The CSM routes hydraulic fluid to the air handling unit, or AHU. The AHU uses hydraulic fluid to run its two-speed fan. The AHU supplies a flow of cool air to reduce temperature rise caused by the heat generated by the vehicle's electronics. The CSM also routes hydraulic fluid to the vapor compression system unit, or VCSU. The VCSU uses hydraulic fluid to run its internal pump, compressor, and fan. The VCSU uses a heat exchanger in conjunction with the AHU to help cool the vehicle, and it also helps remove excess heat from the hydraulic fluid. Let's review the main points of the hydraulic system. Hydraulic fluid is stored in the reservoir. The main or auxiliary pump will send fluid to the hull distribution manifold, which in turn distributes it to the bilge pump, parking brake and vista gauge, and the heat exchanger. Oil also flows from the hull distribution manifold through the hull turret slip ring to the turret valve assembly, which in turn distributes fluid to the main accumulator, the pressure gauge, the ready ammunition door, the azimuth servo, the elevation servo, and the manual elevation hand pump accumulator. On the M1A2 SEP V2, fluid also flows from the slip ring to the thermal management system. The hydraulic system on the Abrams tank is vitally important. In battle, the speed at which the turret and the main gun can be moved, aimed, and fired can spell success or failure. By learning everything you can about the maintenance of the hydraulic system, you'll be performing a highly important task and you'll become an important member of the team.